Hey everyone, welcome back to the workshop, and today I'm looking at another laser. This one is from the Longer 3D company. I am familiar with them from 3D printers. I have one of their resin-based printers, but I have not had a chance to try out one of their laser engravers. And so they've had their Longer Ray 5 version out there for a while that has 5, 10, and 20 watt diode lasers, but this is the new B1 series, and specifically this is the 20 watt version. So they also have a 30 watt version of this, and I will touch a little bit on this towards the end, but we're going to be taking a look at this laser. I'm going to be doing my usual tests on it and kind of giving you some feedback on what I think about it and the pros and cons. So if that's something that interests you, let's jump right into it. All right, now before we jump into the review, let's just go over some of the quick specs. So as I mentioned, this is the 20 watt version of the B1 series from Longer. And so that means it has 4 diode emitters that are combined together through mirrors and lens into what they're calling 20 to 24 watt diode range. So I would put this solidly as a 20 watt diode laser. Now, it does come down to what they say is a 0.08 by 0.1 millimeter working spot size. So I'll do my best to run a Kerf test later and show how close we're getting to that. One of the nice things about this one is a little bit bigger than your typical diode laser. It is a 450 by 440 millimeter, or about 17.72 by 17.32 inch working area. We'll take a look at that, trying to make sure that we can test and ensure that it does meet that size. And one of the big things they talk about is that it does have engraving speeds of up to 36,000 millimeters a minute. And so that's getting up there pretty high in the speeds. Again, we're going to need to take a look. Does the power pair with that speed pretty well, or can it go that fast, but you just can't burn that fast? And then one of the other nice features about this laser is it does have what they're calling Smart Air Assist, and that's where the air pump is controlled through the board, and with switches in Lightburn, you're able to turn that on and off via the layer settings. And so we will take a look at all of those features. Right now, I'm going to kind of breeze through the setup a little bit. I try to leave those out of the general review videos. Not everyone wants to see them. If you want to see the assembly, I actually did the live stream and assembly on this. I'll have a link down below to that. You'll see me work through it, but overall it was fairly simple. My one gripe is that, and this may be because it was a pre-release, is the directions were fairly basic. The instructions came on this it's a quick start guide just on one sheet of paper here. And they do have diagrams. They call out the various parts, but all the installation setup are on this side. And while it does a decent job of walking through it, and I was able to get through it, there are a few spots where I was looking at the photos, just trying to go, okay, do I have this right? And a couple areas where I felt that a little more information would have been helpful. But it's fairly simple to put together. You do start by just putting about 2 screws in each corner to pull the frame together. You do need to add the belts on the sides, and there are side caps that you need to take off to make that easier to put on. So that's one of the things I didn't necessarily see called out in the instructions. Once you have that in, you do need to install the limit switches. That's something I'd kind of like to see done at the factory, but it's not a huge deal. Just an extra little hassle on this end that I think they could be installed at the factory. After that, you've got your cable routing and your air assist connection, and then we get into the software setup. Just touching on a little bit of the operation of this laser, it does have the limit switches, so it can set up in home. However, when I went ahead and set this up in Lightburn, I noticed that its homing speed was set really, really slow. I think it was set to something like 500 millimeters a minute. And so if your laser's starting at the back and off to the right and has to move all the way to the front and to the left, it can take quite a while to get there at 500 millimeters a minute. So that was something I went in and changed. You can use your $25 command in your console, or go into your device setup within Lightburn, make that change. I bumped it up to about 1500 to 2000 millimeters a minute. And this is for the seeking. That's where it's going to touch off the limit switches first. And then I left the actual calibration one the second time it touches off slower, just to ensure that it's not bouncing around and getting false areas there. But I just found it kind of odd that they had that set up really slow, but it's an easy fix to adjust. The other thing is this module does have your typical fold down foot for focusing, and then it has this knob that releases the module from its dovetail, and then you can slide down and touch off on that point. The one thing, this is pretty typical of a lot of these lasers, but what I don't like about this one is that this knob is really close to this back gantry bar. And so I just find it a little bit awkward to make sure that I'm getting a good grab on this knurled end of this screw. And so I would like to have seen this maybe out just a little bit more in a way that it's easier to get at. Now, when setting this up in Lightburn, I was able to get it to auto detect, and then it found that it was the right size laser and it installed it. But when I started running my first tests, I was running into some weird issues where on the cut tests, it would do the first square and then it would pause and the laser would stay on for about half a second to a second, and then it would move to the next one, pause again. And I ended up with this grid pattern where they were kind of cutting out okay, but it also was pausing, and in that corner, it was getting an overburn. And then when I was doing the engraving tests, I was noticing on the ends, they were very dark, like it was overburning. And I started playing around with my overscan settings, tried to make sure that constant power mode wasn't turned on. And I just was kind of having a little bit of a struggle there. So I did reach out to Longer, tried to get some support. They suggested some changes. And meanwhile, I also was contacted by another YouTuber named Steve Makes Everything. He does a lot of laser engraving reviews as well. And he asked, hey, I see you're working with this laser. Have you noticed a couple issues with this? And we compared notes and we were having this similar issues. And through talking back and forth with him, also in some conversations with Longer, kind of was narrowing in on that constant power mode. Well, went back and looked into the device setup, and when it auto detected, it actually detected as GRBL _ M3. And that's kind of more of a legacy type setup. And it was really the incorrect driver. It forces the laser into constant power mode, and it wasn't allowing Lightburn to make the changes that the laser wanted to make with its acceleration and deceleration. So I simply went in, changed that from the M3 to the regular GRBL, and then started rerunning my tests. At that point, everything was working smoothly. Everything was working great. And so I was able to move on from there. But it was a little bit of a hiccup. And so if you're watching this and wondering why your laser is maybe acting a little funny, don't get mad at Longer. Just go in, check your device type, change if it's set up as a GRBL _ M3, change that device type back to just the regular GRBL. So it was great to be able to collaborate a little bit with Steve Makes Everything and get that back and forth. I'm all about collaboration with other creators. I am not about competition with them. So it's always nice when we can help each other out. So I'm going to link down to his video as well. He was actually looking at the 30-watt version of the same laser, has his review out there. Go check him out and check out the 30-watt version if you're interested in this one but want a little bit more power. Right, so then I wanted to start my tests. And if you've been on this channel for a while, you know that I do a lot of work with 3mm Baltic birch. Now, this does tend to be a little bit denser than your typical craft plywood, but it's kind of my baseline of what the various lasers will do. I first started out with stock setup with the 3mm Baltic birch, and here you'll see the results. If I can get it to focus, there you go. And you'll see that it is cutting up to about 450 millimeters a minute in that 90 to 100% power range up there. And that is pretty typical for a diode laser like this. It even squeaked out a couple 500s, but if I flip this around, you'll kind of notice maybe that there is a little bit of, come on, let's focus on there. There's just a few fuzzies back there. And that is because I did have to push them out for it to be cutting at that power. However, what I also noticed is that there's a lot of overburning, and you see a lot of that staining. Come on. So you'll see a lot of that staining on the wood, and it is cutting out cleanly, but even on the back side, you'll notice there is kind of some overburn and staining outside there. And that's something that we don't want to get, especially when using an air assist. So I took a look at the air assist. I made sure that the hose wasn't kinked, that the valve was all the way open, that we were getting air through it, and we were. However, what I also noticed is when I really dug into it, took the module apart, is that the nozzle on the very end of the cone is very wide to what I'm compared and what I'm used to seeing. So that really opens it up. It's actually bigger than the supply hose that the air is providing. So instead of pressurizing the air, I think the air is expanding and it's still flowing out, but it's not getting that nice jet stream of air. So if you've ever played with a garden hose and you put your thumb over the end, that water starts shooting out in a finer stream, but a lot faster and a lot farther. That's kind of the same fluid dynamics we're trying to get with these air currents, is that we're wanting to push that air down into the cut, really push the debris and the smoke out of the way to help make our clean cut. So just to play around with that, I did take some tape and taped over the nozzle, and then use the pulse feature, just hit a quick shot of laser through that tape so that it would open it up just the width of the laser kerf. And then I reran my tests. And as you can see on the side, then my cuts came out much cleaner. They really didn't improve the speed any, but both on the front and then as well on the back side, you see how much cleaner it is with that more compressed stream of air going through that nozzle. So the air assist does work for what it's doing, but it's I think if we had just a tighter nozzle on the end of that, we would see even cleaner cuts and maybe more efficient cuts in some materials. So with that, I went ahead and started testing other materials. So knowing that the typical material for people is probably going to be sourced more at your local big box stores, I do have some of that on hand and wanted to test this as well. This is closer to 1/4 inch material, though the one here, the thicker one, or the lighter colored one, is from Home Depot. This is kind of their 1/4 inch sanded plywood. And here, as you can see, are my test cuts. You might notice, if I can get it to focus again, that on this side here, we do have this one abnormality that's popping up above where it's higher and lower power, it's not. And then over here, we're just getting at the far end one. And so that's at the, that abnormality was at 450 millimeters a minute at 90% power. I kind of discounted that, and that's why I ran this test a couple more times just to make sure that consistently we were getting cuts at the same power and speed. Every once in a while, you're going to get a light pocket, you're going to get a heavy pocket. So I like to run these tests a couple times, especially when cutting, to ensure that I'm not getting some abnormal readings. So with this Home Depot material, 400 millimeters a minute, 90 to 100% power, worked out really well on both sides there. And as you can see, the back side too, if we can get that focus in, fairly clean other than down at these high power, low speed settings. So then I also ran it on some of this 5 millimeter plywood from Lowe's. And here again, we have about the same scale. We're getting up there, just barely squeaking into the 400 millimeters a minute, 100% power. Even going into that 450, but again, I'm not going to count that one as it's kind of the top end. So for a 20 watt laser, working really well at both the speeds on this size material. All right, so now we want to look at the engraving capabilities, and this is where we're going to get into those stated speeds of up to 36,000 millimeters a minute. And so I started out using the light burn grid for this, and if I can get out of the frame there, you can see there is the gradient for that. And looking at this, it really drops off pretty quick. So I started going from 8,000 millimeters a minute and 10% power all the way up to 36,000 and 100% power. And it really dropped off pretty quick at those speeds and those power levels. I'll show it to you again. And so seeing that, I wanted to then kind of make up a slightly larger grid and do it so that it would scan across the whole thing, make sure that we're actually getting the right speeds. And this time I limited it to 5,000 up to 19,000, starting at 20% power, going up to 100% power. And that's where you see this grid is at. And that is a much better representation of what we're going to be working with. And so as you can see at the top, 5,000, definitely we're getting way too much burning there. It's creating a lot of spilling over and such. But I kind of was landing in this 11,000 millimeters a minute range. You get a decent coloration, just a little depth. You could bump it up to 1,300 if you didn't want the depth and that was dark enough for you. But looking at this 20 watt laser, I think for engraving on this material anyway, my top running speed for things is going to be right around that 11,000 millimeters a minute range. I wanted to do a little bit more of a real world test. So I went ahead and took my logo and the longer name and went ahead and put it on this 3 millimeter plywood. And so this is actually done with multi-mode. So if you can see, there is actually a little bit of an outline to each of the letters. And so what I did is I set it up for a regular fill first. And this was done actually at 12,000 millimeters a minute, 100% power. And it came out fairly dark. I don't know that I'd want to go much lighter on this. And then I followed that up with an outline of 2,500 millimeters a minute at 50% power. And it just gives it that extra little definition there that you see. So that's a nice way to kind of maybe trick the sharpness of your engravings, give it a little bit of pop. Now, continuing on with my real world tests, wanted to go ahead and run a longer job because sometimes just cutting out squares doesn't tell the whole story. And so I ran this file. This is a pterodactyl file that I've had for a number of years. I've cut this out on my CNC and a few other lasers. And so I scaled this down for the 3mm wood and cut it all out. Nicely cut out of the 3mm craft plywood, running at about 375 millimeters a minute and 100% power. Everything popped out, and then I was able to glue it together. I didn't make any kerf adjustments at this point. It was just kind of testing around to see how it would work out. And so that came out pretty well. So then continuing on with real world, I wanted to make kind of a museum style placard for it. And so this is about a 3 by 5 inch card, and I went ahead, and this is an image engraving followed by a boxed vector engraving, and then this is just a bunch of text. And so as you can see, you can still read it. It's a little bit fuzzy, but we are talking about some real fine text. If I bring up a ruler to show you just how small some of this text is, you can see we're looking at a couple 30 seconds in height. I can get the light to shine on there right. It's very small text, but it's readable. And so that's kind of indicating that our spot size is maybe pretty close to that 0.08 by 0.1 millimeter. And depending on your material, how crisp that is, you can still get some quality engravings out of it. All right, so I wanted to see what our kerf was looking like, and this will give us a little insight into that focus spot size of 0.08 by 0.1 millimeter. Now, that beam is going to have variations, and the depth of your material is going to create more burning or not. So it's not really going to give us the true size of the beam, but it's going to give us an idea of what the kerf's looking like, and is it square, is it rectangular, and how close to it is that. So I used some 3mm plywood, and I went ahead and cut out 3 1-inch squares within Lightburn, and you'll see a bunch of numbers all over this. I have a whole video on figuring out kerf, but what I do is I take your numbers, your numbers this way and add them all up, and then average them out, and your numbers this way, add them all up, average them all out, and then I get an idea of what the overall cut size is. Then I got to divide it by 2 because you got lines on each side. And that kind of gives us our approximate kerf. And so what it kind of ended up being is, as far as the inch measurements, we're looking at for the top and bottom, we're looking at 0.9905, 0.9905, 0.9885, and then on the top and down ones, were 0.995, 0.996, and 0.998. And so when I averaged those all up, I was coming up with 0.9932. And then through the simple math of divide that or subtract that from 1, divide by 2, and then multiply by 25.4 to get our metric, I actually came up with 0.086 millimeters for the average kerf in this material. So that's telling me we're probably pretty close to that 0.08 by 0.1 millimeter spot size. Again, this is just 3 cuts on one material. You would want to do as many as possible to really get a better average and make sure everything's dialed in appropriately. You also want to play with your focus to make sure that you're really getting to the middle of the material, and that's going to give you most even cuts on top and bottom. But looking at this, I'm fairly happy with this to say that we are probably pretty close to that 0.1 millimeter spot size, give or take, for your kerf. So I also wanted to test some thicker material. A lot of manufacturers will say it can cut up to 25 millimeter thick of this type of material and that. Generally, they're getting into the softer woods or acrylics when you get into that thicker material. My idea is that for these lasers, I'm not really going to be working with material that's anything thicker than 1/2 inch. And realistically, I'm going to probably stick to 1/4 inch or less. You get above that and your beam's going to get defocused on the top or bottom, and your speed to get through it is, it's just going to start being to the point where it's not very effective. It's taking a long time or so many passes that it's just, there are better tools for the job. But for some people, this is your only tool that you have, and you may need to do this occasionally. So I took a look at some thicker materials. So started out with this poplar, and this is basically about 1/2 inch material. And so I set the laser up to make this 1/2 inch circle in it. And I believe I set this job up for 3 passes. And actually after 2 passes, I was able to stop it. And this was running at 150 millimeters a minute, 100% power. And it did cut through fairly cleanly. I'll flip it over. You see there's just a little bit of a burn on that side. And then if you can see the edge of this material, it's caramelized, but not like overly burnt. So again, poplar is a fairly soft material, but it was able to get through this in 2 passes, 150 millimeters a minute without any issues. I didn't have any flare-ups or anything. So then I went ahead and grabbed some 3/4 inch aspen and basically ran the same job. I ran a 3-pass job, 150 millimeters a minute, 100% power. And at the end of the 3 passes, this did drop out. And so as you can see, it's fairly clean on the top, fairly clean on the bottom. And again, our material is charred, but not overly burnt. And so, yes, it can do it. It does it pretty well, but at 150 millimeters a minute, I wouldn't want to be doing anything too big, but definitely something possible. Now, they do include a number of safety features built into the machine, so I want to go over those a little bit in my experience with them. One of the first ones that they have is they have a safety lock, and that is this key that's on the top. That if you don't have it in and turned, the machine will not turn on. Now, the bad part about it, this is the key has to stay in while it's running. And that's probably a good idea because it makes sure that you don't leave the key and lose the key and aren't able to unlock or lock it. But I don't like the key sitting necessarily up on top. Anything that's up here can sometimes get in the way. But that's a minor gripe. Again, on the module, it does have this nice shroud. This does come off. And on the front, it has what they're calling this panoramic filter glass. It does a really good job of blocking out the light. However, with that, it also makes it a little bit hard to see your alignment and your framing. So if you need to frame it and you want to turn the laser on, you can do that through light burn, and it just emits a low power, so it just has a nice little light glow. But if this is trying to block out that bright light, it really blocks out that dim light. So it's good that it's on there, but it can also get in the way, making it harder to see. One thing I really appreciate is it does have an e-stop button. This is off in the corner. I like that it's away from the mess over on the left side here of all the cables and the reset button, the power button. This is when something goes really wrong. You hit this button, it stops the motion, it kills the power. It's basically gonna stop the laser from doing anything worse. Then you'll be able to deal with whatever the situation is. Now, to turn it back on, you just simply twist. That's gonna re-enable that power flow. Now, the machine does have limit switches on it on the homing end, so that the laser will come off and touch each one, and that's gonna know, all right, here is the lower left corner, and then the 450 by 440 millimeters away, it's going to know as its soft limits. Now, it doesn't have hard limits on the other side. So if you don't home and you start your machine up in the middle and it tries to frame, it's going to go out of frame and it's going to grind a little bit. So you still need to be careful, make sure you're homing, your machine knows where it is each time for those to be functional, but they are a good safety feature on top of that. So they also include a flame detector, and this is going to monitor the bed for anything that it detects as a flare-up. And so the idea is that if it sees that, it's going to stop the laser. And this one is actually going to bring it back to the home so that the laser head isn't necessarily sitting over maybe the burning area. So this is actually a sensor that's on the inside of the front bar. Went ahead and tested that and needed to get a fair amount of flame before it triggered, but that is something that I believe you can go in to adjust the sensitivity within your GRBL settings. And so it did function, and the laser head did move back out of the way. Again, this isn't something you want to leave sitting and trust that that's going to take care of it. I had a spritzer bottle of water. It's good to have maybe a bigger fire extinguisher as well, just in case. But if you're monitoring your laser and you start seeing flare-ups, you want to stop it, hit it with a little bit of water, and then reset, and you'll be able to go on. If you walk away and think that you can catch it off of a camera and come in, those things can get out of hand in a hurry, and now you got a bigger problem that is going to be more than just some wasted material. So another thing that they advertise they have is a tilt and motion sensor, and that's where if the laser gets jolted or tilted as if it's maybe being bumped off a table, it should stop power to it, throw alarm. Now, I had it in my enclosure. I put it on a low power job, so it was running, and I went in and lifted it up, and I'll have a little video of that, and it never stopped. So I'm not sure if there's a way that you can turn that on or off or adjust the sensitivity there, but it didn't work for me. And so that feature wasn't there. That being said, you really should have this in an enclosure, have it fairly secured to where it's not going to get bumped. And so that's not something I really am too worried about it not necessarily working, because I hope never to be in that situation where I would need it to turn off in that scenario. Because if I have it in one of my heavier enclosures, that's where it's locked down and such, and it gets bumped, I've got bigger issues there. So that's something maybe I'll need to follow up on to see if that's a setting that can be enabled or disabled, because I know that's true on some of my other lasers. But I just didn't find the documentation on that for this one. Now, they do list 2 other safety features on their advertisement for this. One is thermal protection, and the other is offline protection. Unfortunately, the only documentation I got with this was this kind of quick start guide, and I didn't see any more information about that on here. And so I'm not 100% sure what those safety features are. So if maybe they'll come out with some better documentation as these units start shipping, that maybe they'll have a more fledged out manual that I can download and check. But at this time, I can't really speak to what those are, and I wasn't able to test them. All right, so that is going to wrap up this video. I hope I gave you some good information on this laser. I want to thank Longer for sending this out for me to give this review and give you an overview of what it's like, what it can do, some of the things that it's really good at, and maybe a few things that they can improve it on. For an $800 20-watt laser, I think this is right in there with a lot of the competition. It has a few features that are a little bit nicer as far as the auto air assist and the bigger working area. So for someone looking for a sub-$1,000 laser, definitely something to look into. And if you need a little more power, definitely they have the 30-watt version. Go ahead and look at that. You're going to get a little extra cutting power. You're going to get a little extra speed on your engravings. So I will have links down below. They will be affiliate links to some of this. So that does provide a little bit of kickback to me and supporting this channel. But again, no pressure. I just am glad I can take a look at some of these lasers and check them out for you, give you some input, and help you make an informed decision. So if you're looking for that, definitely check out some of the links down below. And there'll be other links to where you can find out more about what I'm doing in my workshop and what I'm doing next. So if you like what you saw here, you thought it was good, hit that subscribe button, hit that like button, leave me a comment if you got a question about this or anything else, and I'll be happy to get back to you. Anyway, thanks again for stopping by. I'm glad that you were able to check out this video, and I hope you can get out into your workshop and make something too. We'll see you next time.